Today we're going to look at similar figures and find missing side lengths. All similar figures are really just proportional relationships. If figures are similar, that means that they are proportional to one another, which means I can solve things as a proportion. So if I look at these 5 rectangles here, let's start with figure A, which is the purple one. I want a color code. Color code is going to help me so much in the long run. So make sure when you do this in a little bit on your paper, make sure that you're using colors. You can use any 2 colors. You do not have to use the ones I use. So I'm going to highlight all of my long sides yellow. So if I look at figure A, the long side is 8, B is 4, D is 6. I'm sorry, I skipped C. C is 2, D is 6. And E is 10. Now I'm going to go ahead and just write those in really quick so I don't forget. So A was 8, B is 4, D is 6, C is 2, and E was 10. And then I'm going to color all of my short sides green. So I'm going to highlight all the short sides green. And I'm going to highlight my table green as well, just to kind of keep track of what's what. And now I'm going to fill in all of those sides. So I have 4, 2, 1, 3, and 5. Now, I'm going to show you 2 different ways to find a missing pair or a missing side length, or if just to tell if figures are similar or if they're proportional. Similar and proportional, those 2 words are interchangeable. So if it is proportional, that means it is similar as well. So if I look at this, what did I do to my long sides to get my short sides? Many of you probably say divide by 2. However, what also means divide by 2? What can I multiply by and it mean the same thing? So we know that when I divide fractions, I divide any numbers, especially when I think about fractions, we have that rule, keep, change, flip. So that's ultimately what I'm doing here. So I'm going to keep whatever the first number is. In this case, it would be the long side. And instead of dividing, I'm going to change it to multiply. And instead of 2, I'm going to flip it to its reciprocal and get 1/2. Because if I had, say, $100 and I gave you half, all I'm doing is dividing by 2. So right here, instead of in the process column saying divide by 2, we can say I multiplied by 1/2 all the way down. All right. Now, here's my table. You can see in the process column, it's already been filled out. Now, the question here says, at the bottom, it says, if the long side is 24, what is the length of the related short side? So we have to figure that out. Well, I know many of you can look at that and say, well, the short sides are all half of the long, so half of 24 is 12. And absolutely. But there's 2 ways I can look about solving this as well. The first one, because I said it is proportional, it is a proportional relationship, that means I can set up a proportion to solve it. So for example, if I said long to short, and I look at the first row, figure A, I can say long side was 8, short side was 4. Therefore, I can set up a proportion. Now to figure out, say, figure F, if you want to call it that, 24 is on the long side, and my missing, or I can put my Y, since on the Y side, is the missing there. So to solve, I'd multiply by 3. So here times 3, and either way, I still get 12. The other way, which is going to be extremely helpful for your homework today, so pay attention to this second way. The other way is just simply making an EFT. So I'm going to make long and then short. Oops, short. Now, I'm just going to use the first one, figure A, because that's the one that's just written first. I could really pick any of these, and I'm going to say 8 and 4. Now, before I count by 8s and 4s, what I want to do is this fraction, because it now looks like a fraction, I want to simplify it. Okay, I want to simplify it. So 8 and 4, I can divide them both by 4, and I get, I get 2 and 1, which I also see right here on my table. And remember from a previous unit, that's also could be thought of as like a unit rate because 1 of something. All right. Now I'm going to do my EFT. I'm going to count by 2s. 4, 6, 8, 10. And I'm going to keep going until I get to a 24. And then the same here, 1, 2, 3, 4. And again, I'm going to keep going until I get whatever that missing number is. Now, I could have also used the 8 and the 4 that I originally had. That would have worked, but not always will that work. That's why I simplified it first. So I could have said 8, 16, 24. So 4, 8, 12, that was my missing side length. So again, you can set up proportions to find missing sides, or you can make an EFT to find the missing side length as well. On today's paper, you're given several rectangles, and you have to find what is proportional. So set up each one as a table kind of like this that I created, long and short side, and fill in for each figure the long and the short, and then simplify and create your EFT. So for example, I know that this 8, 4 rectangle is similar to the 24 because I see 8 and 4, and I see it here too inside of my EFT. I see the 24 and the 12. So let's look at another. If I looked at this one, again, same idea. So notice here, it says labels 2 times, because when we talk about pictures, I need to make sure I'm looking at the correct picture. So I'm going to look at this triangle first, and it's labeled A, B, C. So I'm going to put A, B, C. And then I'm going to look at the other triangle next, and it's D, E, F. So I'm going to say D, E, F. And you can also see the names written up here. Now, I'm going to highlight the missing side that I have. So the missing side I'm solving for is right here. Now, I want to look at the other triangle and find the same side that corresponds to that. Corresponds means it's at the same location, just in a different figure. So this one was on the slanted right side, so I need to highlight the slanted right side here as well. Also, if I look back up at the name, it went EF for the last 2 letters. Well, BC are the same, the last 2 letters in that one as well. So I know those 2 correspond. So I'm going to highlight this green because that's going to be my green side. Now, if I look at the triangle on the left, I see that, but do I have a length here to use? No. So that's not going to be a side I want to look at. I have a length here and I have a length here, so that looks good. So I'm going to go ahead and highlight that. So now if I plug in my numbers, the green on ABC was 3. The red on ABC was 5. The green on DEF was X, and the red on DEF was 15. Now, again, 2 ways I could go about solving this. I could set up, because it looks like a ratio table kind of from 6th grade, I could set up a proportion and solve it and figure out what it is that I'm doing to get X. Or I could set it up as an EFT, like I mentioned earlier. I know 3 over, let's say 5, if I use these 3 over 5. Well, if I keep that going, I'm going to have 6 over 10 and then 9 over 15. Well, guys, 9 is my missing number. And I know that because 5 times 3 is 15 on the proportion, and 3 times 3, well, there's your 9. So again, on today's paper, I would strongly suggest you make an EFT to find out which groups of shapes are similar, because once you make your EFT, you can determine if they're similar or not real fast. If I've got 2 rectangles and I needed to know if they're similar, I'm going to take my long and my short side. So on the first rectangle on the left, long side is 3, short side is 2. If I made an EFT using those numbers, I would get 3, 2, 6, 4, 9, 6, and so on. Well, I see a 4 here, which I see a 4 here, but does it match the other number? No. So therefore, it's not proportional. It's not similar. However, if this said 6, then yes, they would be proportional. They would be similar figures. So use the rest of class to work on this, and what's not done needs to get finished tonight.